Hey there everyone, it's your math tutor, Calculus. Today I will go over the proof of the leading coefficient test. Well, I will show you all the proofs, especially those taking calculus or no calculus. Before anything, I'll make a video on limits in the future. For now, I'll try my best to show and explain the proofs. So first off, we have f of x is equal to x, which means it's the name of the function. It could be any other letter, and x, which is inside the parentheses, will be the input value. F of x equals x is like y equals x. Y or f of x are the output value after plugging in a number for x. Remember, x represents any number. The next topic is about limits. And the limits are taught in calculus. So, the first example at the very top, you'll see that I set the limit to negative infinity and positive infinity. Now x has an odd exponent. So as x approaches negative infinity, it will get closer to the y values of negative infinity. We then plug in negative infinity for x because negative infinity is always less than any number going to the left direction. And positive infinity is greater than any number going to the right direction. So you see, infinity is a concept, not a number. So as we plug in negative infinity, it will get closer to the y values of negative infinity. And when we plug in positive infinity, we get closer to the y values of positive infinity. All this because we plug in negative infinity and then positive infinity to the function. And x is raised to the first power, so it becomes the same. Negative infinity, the same is true with positive infinity. So the graph falls with negative infinity and rises with positive infinity plugged in into the function. Now, next example. The new function is f of x equals negative x. So we start with the first example. Negative infinity plugged into the function negative x, and negative times a negative will be a positive. Next example. Positive infinity plugged into negative x will result in negative infinity, because negative times a negative equals a positive. So the graph rises with negative infinity as the input, and the graph will fall to the right with positive infinity. Next example, we have a new function f of x equals x squared, with x being raised to the second power. We plug in negative infinity to x squared, and negative infinity times negative infinity is negative times a negative will be a positive. So we get positive infinity. Next we have positive infinity. We put into the function, which is x squared, and positive infinity times positive infinity equals a positive infinity. The sign doesn't change. So the graph rises with negative infinity to the left, and rises with positive infinity to the right. Finally, we have a new function f of x equals negative x squared. We input negative infinity to negative x squared, and negative of negative times a negative infinity will be a negative infinity. Next, we have positive infinity, and we plug that into negative x squared, and negative of positive infinity times positive infinity, and it will equal negative infinity. So the graph falls to the left with negative infinity, and falls to the right with positive infinity. So you have negative infinity is a concept of all the x input numbers going to the left side, and positive infinity with the numbers going to the right side, infinity, forever. These patterns repeat, and thus the rule of end behavior was born. It's just a matter of the sign being changed, because because it's raised to a certain power. Well, that'll be it. Don't forget to leave a comment and support my channel and hit the subscribe button. Thank you.